All right, I'm having a lot of trouble with videos, so I hope this one goes through. Okay, and I hope you can get it. We want to try to move on to subtracting integers. Now, I hope you remember how to add integers. That's what you had the last 5 IXL assignments on. And again, I hope you remember that the 2 basic rules are same signs, add and bring down the sign, different signs, subtract and take the sign of a larger amount. Now, I did that by using the fact that positive meant having and negative meant owing and addition meant to combine. And we did logically figuring it out, okay, which one was which. Or we did it with a number line, or we did it with the little disc, okay? And again, I think even one of your IXLs was with a number line and one was with a disc. Now, I don't teach subtraction with the number line or a disc because, to be honest with you, it doesn't make sense to me, so I don't think it makes sense to you. But I do use logic. But I'm not going to use the fact that positive means having, negative means owing, and subtraction means taken away. Because if I do that, I'm going to come up with 4 new rules, okay, from when I have same signs and different signs. And it actually gets even more complicated than that. It's actually 8 new rules because it depends what one you're subtracting from which. Because a positive minus a negative when the positive is larger is different than a positive minus a negative when the negative is larger. So again, it's kind of complicated to use those rules. You could do it, but I wouldn't suggest it. As a matter of fact, what I would suggest you use is use the fact that subtraction is the opposite of addition. Now again, I hope everybody knows that when we solve equations we use that, didn't we? To get rid of addition we subtract because it's the opposite of adding. And that's how you take it away, okay? And to get rid of subtraction or add because it's the opposite. But anyway, with integers, that can become very helpful. And you might say, I don't get it, how is that going to help me? And I say, I'll give you a very quick example. When my wife and I were getting married, we wanted to buy a house. And we didn't have enough money for the down payment on it. So I asked my brother to lend me $2,000. He was very generous and he lent it to me, okay? And then after we bought the house and after we got married and bought the house, okay, I went to pay my brother back. And he said, no, don't worry about it, that was my wedding gift, okay? So think about this for a minute. I owed my brother $2,000, okay? So that's a negative 2,000, right? And he took away the fact that I owed him $2,000. Isn't it true that when he took away the fact that I owed him, he actually gave it to me? He didn't give it to me originally, he lent it to me, and I owed him the money. But when he took away the fact that I owed it, he gave it to me. And that's a very important fact, because that's saying that minus a negative is the same as adding a positive, okay? And again, it's that double negative. Like if you say, I ain't got nothing, that means you got something. And if you think about that kind of deeply, you can kind of realize what that means. Pretty sure Miss Donnelly talked to you about no double negatives. I know Miss Donnelly talked to you about never saying ain't, all right? But again, that whole idea that they're different allows you to come up with a rule for subtraction that uses the rules for addition. Because this is what I recommend you do when you subtract integers. Change the subtraction problem to an addition problem by changing the number you divide by to its opposite, and then follow your addition rules. By the way, look at this definition or rule very closely, because it took me about 20 years to word this the right way. And go, 20 years? You must be pretty stupid. No, I did what most people do. They just say, oh, just change subtraction to addition. But that confuses people, because you're not always going to add when you change subtraction to addition. And you go, but if you change subtraction to addition, then you got to add. No, you got to follow the addition rule. And remember the addition rules. Same signs add and bring down the sign. Different signs subtract and take the sign a larger amount. Now, you might say, wait, I'm confused. So in other words, I changed subtraction to addition so I can subtract? And believe it or not, that sometimes is true. And you might go, whoa, that doesn't make any sense. Well, let's look at a couple of situations of what I'm talking about. Like if I had a problem like this, 5 minus 9. Now, first of all, you've been taught your whole life you can't take 9 away from 5 because 9 is bigger than 5. And that's true. You can't take 9 away from 5. And you say, well, good, then let me not do this problem. But let's first of all realize this 5 has no sign, so that makes it positive. The 9 has no sign, so that's positive. And remember, no sign means positive. So now, excuse me, if I follow this rule by changing the subtraction problem to an addition problem, by changing the number you subtract by to its opposite, okay, then a positive 5 minus a positive 9 becomes a positive 5 plus a negative 9. Because the number you subtract by is in the back or bottom, just like the number you divide by is in the back or the bottom. So since it says minus a positive 5, the double negative canceling each other out becomes plus a negative 5. So I change the subtraction to addition, and I change the number subtract by to its opposite. So now, I don't add, even though it's an addition problem, I follow the addition rule. And what's the addition rule for a positive plus a negative? Different signs, subtract and take the sign a larger. So you see, I actually changed subtraction to addition so I could wind up subtracting. But you say, but Mr. Adu, you can't take a larger number away from a smaller number, so I can't take 9 away from 5. You're right. And when it was a subtraction problem, you couldn't do anything about that. But now it's an addition problem, so you can do something about it. Because we have something called the commutative property of addition that says you can change the order. And you'll get the same answer. So instead of a positive 5 plus a negative 9, you can think of it as a negative 9 plus a positive 5. And again, you would subtract and get 4. But now you take the sign a larger amount, and your answer is a negative 4. And again, you say, but Mr. Adu, couldn't I have just gone 5 minus 9 is 4? No, because it's not 4, it's a negative 4. And you say, okay, Mr. Adu, couldn't I just go 5 minus 9 is 4, and then just make sure I make it negative? That actually would work, but that would only work in 1 of 8 situations. And why learn something that only works 1 out of 8 every 8 times? That's crazy. And why come up with 8 different rules that you have to memorize? If you just follow this simple rule, change subtraction problem to addition problem by changing the number you divide by to its opposite, and then follow the addition rule, it becomes very, very easy. But for some weird reason, people in 7th grade refuse to do that. I've had people who have gone through and failed integers over and over again just because in subtraction they want to come up with rules. Okay? By the way, this whole idea of changing subtraction to addition by changing the number you subtract by to its opposite should remind you of dividing fractions, because we did the same thing in subtraction, in dividing fractions. If I had something like 2/3 divided by 3/4, Didn't I change division to multiplication by changing 3/4 to its reciprocal? So I did the same thing. I changed from an operation to its opposite operation by giving the reciprocal. So 2/3 divided by 3/4 is the same as 2/3 times 4/3. And nobody in here would ever try to do this without changing it to this first. So it's the same thing here. If I have a -8 minus a -2, don't try to take a negative minus a negative. Instead, change the subtraction problem to an addition problem by changing the number you subtract by to its opposite. So I'm subtracting by a -2 because the number I subtract by is in the back. So I make this problem a -8 plus a +2, because minus a negative is plus a positive. Like if you take away owing, it's like you gave it to them. So now I have a negative plus a positive. But again, I have to follow my addition rule. So what is my addition rule for a negative plus a positive? Different signs, subtract, and take the sign a larger amount. So 8 minus 2 is 6, and the larger amount was negative, and your answer comes out to be a -6. And once again, no one would ever try to divide fractions before they changed it to multiplication. No one should ever try to subtract integers before they change it to addition. And you say, but Mr. Adu, I noticed in both cases, after you change the subtraction problem and addition problem, you wind up subtracting. So why can't I just always subtract? Because you could have a problem like this. Again, if you had a -13 minus a -4, again, change the subtraction problem to an addition problem first by changing the number you subtract by to its opposite. So subtraction becomes addition, and the number I'm subtracting by in the back becomes its opposite. What's the opposite of a -4? A +4. And then a -13 becomes a -13 still. By the way, now I have a negative plus a positive. What's the integer rule for a negative plus a positive? Subtract and take the sign a larger amount. This was a bad example. I gave you an example that was just like the one I gave you a minute ago, because we did wind up subtracting. And you say, you see, Mr. Adu, you're always going to subtract. I say, no, I just made a dumb mistake. So let's try another one. Let's try a -8 minus a +5. Now again, I'm going to change the subtraction problem to an addition problem by changing the number you subtract by to its opposite. So this becomes a -8, excuse me, change subtraction problem to an addition problem, and change a +5 to its opposite, which would be a -5. Now I have a negative plus a negative. I have the same signs. So what's the rule when you have the same signs? Add and bring in the sign. So 8 plus 5 is 13, and then I make it a -13. So again, you do add half the time and you subtract half the time. And you go, but Mr. Adu, how will I know whether to add or subtract? Follow your addition rules. If you wind up with the same signs, add and bring down the sign. If you wind up with different signs, subtract and take the sign a larger amount. And again, about half the time you change subtraction problem to addition problem so that you can add, but half the time you change the subtraction problem to addition problem so you can subtract. And again, you go, well, that doesn't make any sense. I say it does if you follow the addition rules when you make it an addition problem. But it's not just going to be an addition problem. It's not magic. It's not poof. It's suddenly addition. The only way you can change subtraction to addition is to change the number you subtract by to its opposite. So that's the rule for subtracting integers. And again, some people are very hard-headed and they refuse to just follow it. But if you follow it, it's as easy as dividing fractions. Because once you change division to multiplication, by changing them, you divide by to its reciprocal. It's easy to divide fractions. It's just like multiplying fractions. So it's the same thing here. Once you change subtraction to addition, by changing them, you subtract by to its opposite. It's easy to subtract integers. It's because you're just adding integers. And again, I noticed on IXL, almost everyone who did their assignment on IXL did fantastically great, got all 100%. So you understood it on IXL, how to add integers. So if you can change the subtraction problem, addition problem, you'll understand how to subtract integers. So you will have an IXL assignment on subtraction, so good luck.